lesson 10.1, we're going to look at inverses of simple quadratic and cubic functions. So I've gone ahead and given you a graph of what the parent function of a quadratic looks like. And remember, a quadratic is like an x squared. That's the parent function. So I have a point at 0, 0, 1, 1, negative 1, 1, 2, 4, and then negative 2, negative 4. So I've listed those out here. And then I've also made you a mapping diagram, which we did back in lesson 1.4 when we talked about inverses. And so like the negative 2 got mapped to the 4, the negative 1 got plotted at 1, 0, 0, 1, 1, and then the other point 2, 4. And so a quadratic is a function because each input over here is just going to one number. Right? Now, when I talk about inverses say like you switch the x and the y. So if I were to switch this x and the y, and I looked at the map, let's say the inverse map, okay, if I switch these, then I would have the 4 mapping to a negative 2. I would have the 1 mapping to the negative 1. I would have 0 mapping to 0, but then I would have 1 mapping to a 1, and then I would have a 4 mapping, oh, the 4 is right here. Then I would have a 4 mapping to a 2. And so the inverse would not be a function. Oops, sorry about that. So what's going to happen is that they're going to restrict the domain. Okay, so for example, they're going to, in this homework assignment, they're going to say, you know what, we're going to look at a quadratic only if the x's are greater than or equal to 0. And by doing so, that eliminates those ordered pairs. And so if they eliminate those ordered pairs, then I would only have the 0 being mapped to the 0. I would only have the 1 being mapped to the 1, and the 4 being mapped to the 2, which then would make the inverse a function if the x's are greater than or equal to 0. So they're going to change up the domain so that way we can get a function for the inverse. Okay, so you'll see in your homework that they're talking about if x's are greater than or equal to 0. They're restricting the domain so that the inverse does become a function. So the first thing that we're going to focus on is just verifying inverses. So to verify inverses, okay, this was lesson 1.4. Okay. When you do f of f inverse of x, it should simplify down to an x. And then you have to check out f inverse of f of x. And when it simplifies, it should also be x. So if f of f inverse of x equals x and f inverse of f of x equals x, then they are inverses. Okay. So let's kind of review what that would look like. So let's say I want you to verify, oops, f of f inverse equals x and f inverse of f of x equals x. Okay. Let's say I tell you that the first function, f of x, is x squared plus 3. And I say that the inverse, or I say that the function, this function f inverse is the root of x minus 3. All right, so we need to verify this composite, okay? So which means in the f of x function, we're going to substitute in the equation from f inverse of x. Okay, so I'm going to write down my f of x function. I'm going to say x squared plus 3. And now I'm going to take the f inverse and I'm going to sub it in there. Okay, so now I'm going to simplify. A square root and a square cancel each other out, so that leaves me with x minus 3 plus 3. What else would simplify? Well, next, the opposites would cancel, and I have verified that f of f inverse equals x. So now they want me to verify f inverse of f of x. So I'm going to write out f inverse, which was the square root, their x minus 3. And now I'm going to take f of x, which was this, and I'm going to sub it in there. Okay, so if we simplify correctly, I'm going to get the square root. There's nothing to distribute on that parenthesis, so I would get x squared, oh, I copied that down wrong, minus 3 plus 3, which I could simplify to just x squared because the 3's are opposite. And now I could simplify that the root and the square are inverses. And so then I have just an x. Okay, so I have verified that they both equal x. In each stage, you should only have like one thing crossed out. Okay, so here in this stage, it was the squares that canceled out first. But in this first stage, it was the -3 and the +3. In this stage, the numbers canceled, but in this stage, the root and the square canceled. So you should only have one thing canceling each time. Okay, let's try another example where we verify. Okay, so verify f of f inverse of x equals x, and f inverse of f of x will also equal x. Okay, and I'm going to say that f of x is 0.5x squared, and I'm going to say that the inverse of x is the root of x over 0.5. Okay, so starting off with the first one, we're going to say f of f inverse of x equals, so I'm going to look at the f of x equation, and wherever there's an x, I'm going to put a parenthesis. And now I'm going to substitute in the f inverse. So this is what f inverse was. That's what I'm going to sub in there. Okay. And now I'm going to simplify. So what would simplify first here? Well, I have a square root quantity, and they're squaring it, so the square root and the square will cancel. And that's going to leave me with 0.5 times x over 0.5. Now, if I look at this as a fraction, and I put this over 1, I can see that now a 0.5 in the numerator and a 0.5 in the denominator will cancel, leaving me with just an x. Okay, so now let's try verifying the other one. So f inverse of f of x. So I'm going to write out what f inverse is. And wherever there's an x, I'm going to put a parenthesis. And now this time, I'm going to sub in the parenthesis the f of x, which was 0.5x squared. Okay, so if I look at having 0.5 of an x squared, and I divide it by 0.5, the 0.5s will cancel. That leaves me with the square root of an x squared, and a square root and a square are inverses, so I'm left with an x. So I have verified both of those. Okay, this time I'm going to ask, are the two functions inverses? So I'm going to name them a little bit differently. I'm going to call the first function x plus 2 cubed, and then I'm going to call the second function g of x, and I'm going to call that one the cube root of x minus 2. So if I want to verify that they're inverses, I need to do f of g of x, and then I need to do g of f of x. And again, I know that I want them to come down to be an x. All right, so we're going to go to the f function, which is this, and wherever there's an x, like right there, we're going to leave that blank, and we're going to plug in the g of x. Okay, so g of x is the cube root of x minus 2. And then I'm going to go to the g of x term, and wherever there's an x, I'm going to put a parenthesis, and I'm going to put the minus 2. And they want me to substitute in f of x. So f of x is this x plus 2 cubed. All right, so now we got to simplify correctly. There's nothing to distribute on that parenthesis. So I would have the cube root of x minus 2 plus 2 cubed. Okay, so these cancel, and I get the cube root of x cubed, and now the cube and the cube root will cancel, and I just have the x. Okay, if I look here, I have a binomial cubed, which is being cube rooted, so the cube root and the cube are going to cancel, leaving me with an x plus 2 minus 2. Opposite numbers will cancel, and I have verified that I just have an x left over.